I think let's move to the panel since we are also getting delayed. So I would like to ask Rojen and Ingrid to switch on their cameras. Okay, now welcome all three of you for this panel. How new cell technologies and module designs are stress testing the existing reliability standards in a ultra competitive business environment. So, one question to all, we are seeing a very rapid shift in the cell and module architectures. We have TOPCon, BC, heterojunction, and now we are also talking about the evolution of the tandem. And all these are happening really very fast. Actually, sometimes even faster than the reliability standards historically have evolved. So are today's global reliability standards keeping pace with this speed of innovation, or are we reaching a point where standards are starting to follow rather than the lead the technology? So what, your opinion? Ingrid, maybe you can start.
Yeah, maybe. So I would somewhat question if standards were ever ahead of the technology. I feel it was always like there was always rather a delay that a new technology enters the market, and then the standards have to adapt that, and that's usually quite long progress. And so I think once it was said in a presentation that when, for example, the backsheets arrived in the market and the failures there, it was a learning curve of 5 years from it was known that it happens in the field to the standard was adapted with a sequence speed. And so I think it's always that standards are behind, but we keep on working effectively in these IECs consortia to push it forward. And at the moment, there is a lot of attention to the UVID IEC norm or standard, and almost the whole industry is sitting there, including us and all the test laboratories to adapt it not only for TOPCon but also for heterojunction and everything.
Maybe I can jump in. So I have to agree with Ingrid. So this has historically been the case that the standards are always a bit behind, simply because everywhere else there is a profit motive and they want to push new technologies towards it. So there is a motive behind it. Whereas for the standards, that is not necessarily the case. They can't simply jump in and say that, hey, you're not supposed to sell these modules, or somebody's not supposed to buy these modules. That's not the economy that we live in. So in our case, GCL, we can tell you that we work closely with labs, and we, for example, with TÜV Rheinland, and we already work with them on how to qualify our modules, for example. And in that case, we are already working with labs and, of course, indirectly with all these other committees. So we know what can we expect and how can we qualify our modules.
Sorry?
Yeah. I think generally, yeah, I agree with both Ingrid and Rojen that sometimes the standards are a bit behind the products and technology. But I also want to point out that for well, I will take UV for example. UV problem might not be that severe for example, the aluminum BSF or PERC cells, because they both have quite heavy diffused surfaces. That has a lot of field effect passivation rather than relying on chemical passivation alone. But for more so-called advanced cells such as TOPCon and HAT, because the surfaces are so lightly diffused to the extent that some damage to the chemical passivation will cause a lot of difference for the cell passivation. So I think in this case, the standard is not lagging behind the technology, but it also forms a kind of loop. Like you improve the technology and you find that you incur new problem in terms of reliability, and then you have to study the mechanism behind it. Yeah.
But one question just immediately to your answer. So UVID was initially found out in heterojunction. So we all know from the history that heterojunction. But when releasing the top cone, was it not tested? It was initially not a big fuss about UVID when top cone. We were always concerned about LID, LETID, PID, because we know it from the perk. But why those lessons were not really implemented when we are getting into the new technology like TopCon?
Maybe I can start.
Please.
UVID is already part of the IEC 61215. You have the 15 kilowatt hour of exposure, but my understanding is that kind of exposure is not enough for the defects to show. It's only when you hit UVID 60, maybe even for us, we see UVID 60 as a sweet spot between what is realistic and what is let's say possible from a qualification perspective in terms of time and cost.
Okay. Ingrid, I think you were about to say something.
Yeah, maybe I would say, even though metastabilities were known, but at the beginning, according to the sequence, you just put a module into a UV 60 test and then you measure it. So it wasn't clear that there is a light soaking needed in between. And at the beginning, I think there was a lot of confusion about that before we uncovered that there is a measurement artifact caused by metastability versus there is an actual UV degradation happening. And that wasn't so much the case for the perk. Nonetheless, it was known that modules can suffer under metastabilities, but not in that particular sequence and not in a particular case, how we see it now for TopCon. But also, I mean, to extend all the IEC testing for any eventuality, what can happen with some modules, it's also no one can pay for that. It's already that we saw it so quickly was because we extended the normal sequence B IEC testing and we measured in between, like after UV and then after HF and then after UV again. But in a normal test sequence, that's not done. They would just measure at the beginning and at the end. So no one has seen what happens in between. And now probably people do it more, but you can't prepare yourself for every eventuality.
Okay, so I think we unfortunately have to go through all this growing pains, what I usually call. So, whenever a new technology comes in, so we have to probably start, may not be at zero, but I think we have to start every time pretty new with new degradation mechanisms. Okay, so at the same time, sometimes test protocols are equally stressful when we are over engineering. For example, the Fraunhofer ESES report, which you also discussed, Ingrid, in your presentation. Comparative indoor and outdoor test that the degradation is not uniform, and indoor tests are little over engineered. And then you also put a very thin underline, they are very slightly. So is it a cause of concern that, are we over testing, or to be on safe side rather than being sorry, is it better to keep the same test protocols in place for UVID?
Maybe also I can try to answer that. So it's accelerated testing has always had, like, it's always been a thing. You want to accelerate a test because we cannot wait a year outdoors. So we need to stress the module a little bit more. And then there was always the question, is that realistic? There was a lot of discussion about Dampede 1000. Is that realistic, or is the temperature too high there? But if you go lower, then you have to test longer. No one has the time for that. So I think we have to try to simulate it as close as possible to what happens outdoor, but at the same time, we're under pressure to have short testing times. And in terms of a test sequence, what it does though is, even if it's maybe a little bit too high to test 60 kilowatt hours compared to 1 year, But if you test 100 different module types and you compare them to each other, basically you benchmark them to each other, then the test is very valuable. Also, IEC standards only have the aim to somewhat test minimum or one comparable outcome. We cannot test for each environment for this and then that, the accurate thing indoor. That's just not possible. But obviously, if we have tests which out-test materials, let's say there is a backsheet material which is actually stable in the environment, but since we are testing it in the heat at 80 degrees, and so it never passes, even though it would survive in the field, then that's not a good testing then. But this is what we usually say, like sometimes, depending on the module setup, we modify our testing to say, okay, we know what is realistic, we know what the IEC standard does, and we know there is a gap. And so depending on the material combination, we try to adapt it as good as possible for whatever we want to test. Or yeah.
Nice. And so Xinrui or Rosen, do you have anything to say on this?
Yeah, I mean, from a module manufacturer side, I would say that exactly what Ingrid was saying towards the end, that there are 1,000 ways to destroy a module, but the question is it really, does it really make sense for the end client? I mean, you could think of, if you know that you are going to be in a location, you know, with a certain elevation, and also, you know, there's going to be a lot of exposure, UV exposure, you could think of extending the UV ID test, for example, or also whatever you think that the modules could be affected by, you could extend the reliability test for those specifically, and not just rely on the standard IEC 6.15, and not having to test every single module in all the ways that you could destroy the module.
Yeah. For me, I think we also see this phenomenon like of this artifact during the UV testing for our indoor tests as well. And although our extent of artifact is not as big as reported by Fraunhofer, and I want to say that what is more important for us as a cell manufacturer is that although sometimes the so-called exaggeration exists to overkill a product, but it also drives us to think about the mechanism behind it, because it is true that the surface of the current like TOPCon, HAT, BC is quite different from the old architectures. And if we compare the UV results from all the cell groups, we can see the difference, and it makes us to think what causes the difference, and it can like drives us into designing better, I mean, not only higher efficiency, but also more stable products as a cell manufacturer.
Okay, but you know, in a nutshell, if we talk about the UV ID, so you know, we also had a presentation from Hans of Fass, where you know, you have the down conversion film, where UV can be converted into the visible range, and it looks like if we use such material, the problem is addressed. So is it as simple as this, or is there more to it for the UV ID? So to put it simple, when we use such materials, is UVID is being addressed? Are still some hidden, you know, surprises in terms of UVID for TOPCon at least? Yeah, you know, Ingrid.
Yeah. So I'm not like, I think UVID is understood quite well now. I think we see that the modules already improve in their UV reaction. But again, if you answer with a module design change, let's say you use upshifters, downshifting material, then from the polymer side in my mind, I'm thinking, okay, maybe we have to look how stable the encapsulation material is against UVID, and maybe that needs an extended UV testing to look how that reacts over the time, because polymer reactions can be different to the reaction of the cell. to it. And also maybe if you change something in the cell design, in the cell stack, that might cause other implications on completely different behaviors. So we don't know that yet. So every design change, in my mind, makes it necessary to maybe again test a little bit different, to look for that or this or that. But we do see definitely an improvement in our testing over the past year in TOPCon modules.
So overall, you see a betterment, you mean?
Yeah, I think so. Yeah. But it's hard, again, it's hard to compare because the first measurements we had, or everything which was published 2 years ago, you cannot really take as a reference anymore because it wasn't stabilized. So whenever I see charts of this is how UV degradation looked like 2 years ago, is it with or without light stabilization, or is it a data point? So for a year now, we only see with light stabilization. So this is very comparable measurement data. But before that, we didn't do it, so we cannot compare it to these measurement points.
Okay. And Rojen, as an integrated manufacturer, when you are introducing new architectures, like, in today's presentation, you talked about BC, at a scale, what part of your internal qualification process is now more demanding than the formal certification path?
Yeah. So that's a good question, Shravan. So how we tackle this is for all new products, all new cell architectures, we not just do IEC, the standard IEC, but we go one level beyond, which is the 2 times the IEC 61215. So damp heat, thermal cycling, PID, all of those. And then, and at times we also go all the way to 3 times. I mean, I showed some of this data in the presentation just before. So LETID, for example, we do 324 hours for N-type, salt mist class 8, and so forth, and also dynamic mechanical load. So dynamic mechanical load is not part of the IEC, but it's there's a test protocol, so we also do that. We also do, like I mentioned, power measurements, round robin, the golden reference, doing round robin, so that we make sure that what the power that we promise, the power that we flash at is also what the client gets. We also do packaging testing, because packaging is also a key role when it comes to shipping these modules throughout the world. And in the end, we are also part of the PVEL qualification testing. So this is also something that we do. So we do all these things, and together we're able to, I mean, it's a big commitment, right? Over the next 25, 30 years, having to give a module performance warranty. I mean, we could produce whatever we want, but if we're not able to keep up with the warranty claims, then that's I mean, of course, we lose money in the end as a manufacturer, which we don't want to, right?
And I think one follow-up question again, going back to your presentation, you presented your carbon data platform. That across the value chain, you can access the carbon data. So how this can be used from the reliability point of view? How could this help kind of warranty the reliability? Can you explain a little bit?
So we launched the carbon data platform a bit more than a year ago, so this is still quite new for us. But from a traceability perspective, we're able to come to a faster root cause analysis, because in the worst case scenario, if there's some kind of a serial defect on the field, the root cause is the most important. Trying to quickly come to a conclusion on, of course, you can flash it, you can do standard tests to see what the root cause is, but that takes a lot of time. But with this traceability, we're able to come to a faster conclusion on what the root cause could be. So this is one part of it. And the second part is we are also introducing artificial intelligence in some of our manufacturing sites. For example, in the cell manufacturing lines, we're testing that right now. So in the future, we also want to implement this on the module line. And in case of claims, we are able to quickly come to root cause analysis with the intelligent manufacturing powered by artificial intelligence. So all of this put together, the data from the field, data from the manufacturing, and putting this all together in a loop, we're able to quickly come to a conclusion.
Okay. And Xinrui, are there any emerging degradation signatures you see at the cell level specifically unique to TOPCon that the testing protocols today do not stress sufficiently? So are there anything that you are seeing more and more that could probably enter into the testing protocols?
Well, overall speaking, I think our existing protocols pretty much cover everything from the cell end, but I think in context of the current cell technology, there might be a shift of emphasis on the different types of degradation. For example, UV, as we have already had a lot of discussion, and another type of mechanism, another type of degradation mechanism is the DH. In my opinion, it's also a potential problem for high efficiency cell and modules, because the liquid paste now already has very little aluminum in it, so that's a good thing. But on the other hand, the silver paste now is becoming less and less corrosive, because it can increase the cell VOC by 2 to 3 millivolts, and it might be very attractive for cell manufacturers. But potentially this can be bad for the DH, right? Because it does not penetrate the silicon nitride as much as the old paste. So there must be a point to which you cannot keep decreasing the paste corrosivity. So in my opinion, the UV and DH are the two problems that we need to stress for our current degradation protocols.
Okay, so one more question regarding your presentation. So not directly your presentation, Wolfram Hanzo first, he mentioned that, cell is really important. And then the kind of paste which is used in the cell is also important for choosing the encapsulation. And for example, a module maker who is buying cells, unfortunately doesn't have the control on these two elements. So do you help or work very closely with such module makers who are seeking advice for making a most reliable bill of materials? So would you also recommend, how does it work?
Yes, we do. Yeah. Whenever we develop a new cell architecture, or we develop a new materials such as the silver paste, and we have to reliably test. Some of the tests we can do it in-house, like the cells LID, LTID, or maybe cell UV, but we have to put it up into a module, right? We do have some regular collaboration with some regular partners, like module suppliers, and we send our new products for them to use their standard module bombs, and turn it into module and test maybe UV, DH, anything that's related to our development, and they will share the information with us, whether they pass their reliability test or not, and based on that we can decide whether to promote our new products to the public.
Okay. And Rojen, I have a question for you. You also mentioned during your presentation that, multi-cut, not the half cell, but, 2, 3, 3 or 4 can reduce the current, so the hotspot temperature. Do you have any initial results? A ballpark number, how much you can reduce the hotspot temperature?
I have to look into it, to be honest. The exact numbers, sorry, I can't give you a number right now.
Because that was really very interesting for me, because Hank from Longji also said, after 110 degrees, you can reduce it by almost 50%. So if I remember correctly, somewhere around between 40 to 50. So there was a huge reduction in the hotspot temperature. But if someone is staying with the same technology, but with these multi-cuts, if they can reduce the hotspot temperature to an extent, that would be really great, right? Okay, so then Ingrid, so one question, probably a final question to you before we have our final closing remark. You talked about glass, and there are also still lot of uncertainties, what is causing these kind of circular damages. But, on other hand, glass itself is a very large topic. So there is tempered glass and coated glass, different layers, coatings of the glass, and there is also polymer that is replacing the glass. So all these are also part of your radar to evaluate, or you are already overwhelmed with the existing things?
Well, definitely from our perspective, the increase in claims and failure analysis, root cause analysis concerning glass has increased massively over the past few years, and it's still not over. Like, it's coming and going and coming and going. I find it difficult. Sometimes we get modules here which are broken, and it's kind of clear what the root cause is. It might be clamping the mounting structure. But if it comes to the point of that, we see these round-shaped things where we may or may not find a glass impurity. It's not so clear what our answer is, like, because there is no test for it really. So at the moment we are not able to, and I wish we would be able, and we are working on being able in the future, that we can literally separate different glass manufacturers or different glass qualities within a test and say, this is how good module quality or good classes behave, and this is how bad classes behave. But from testing side, we are not there yet. And also the whole topic class quality is huge in terms of, usually in the glass industry, it's tested with destructive tests. So you have bending tests or double ring tests, and then you have a large number, like 100, 200 glasses, and you break them all to get one data point of how good the glass quality is. We can't do that in a PV lab because we only get a few modules, and so we are very limited in actually evaluating the glass quality. We get better and better and better, but it's limiting. And the other part is what I've learned from EPCs, even the process. So you have all the modules installed in the field, and now some start to break, and they need to be replaced. And even that effort, specifically here in Europe, is very cost intensive, because you need to have people walking through the lines, looking at each module, trying to figure out where is the glass breakage. And since it's not so obvious that there is a big wide breakage pattern, it's just little lines you have to find. It's a lot of effort. So we also try to invent and create methods to help with that. But I think we try to get projects where we work together with glass producers to investigate more what can be done on glass manufacturing side. But I feel it's a huge topic, and I'm not jealous of the situation of module producers at the moment to having to look at glass quality in detail.
Yeah, I think that's true. I think, even I would love to talk more, and there are several other questions, but I think we are also limited with time. So one final closing remark from you all. If you had to recommend only one additional test that should immediately be added to the current IEC qualification for new N-type cells, which test it would be? And very simple word, why? And if there is nothing, so you say no. Maybe Ingrid, you can start.
Well, I would agree with the comment which was written in the chat. I would focus a new test on glass quality, and specifically we working on having a low impact test, basically, like not to have a massive mechanical load, but just a little bit of load and a small impact on it to quantify glass quality. That's something we're working on at the moment, and we look still for cooperation there. So please contact me if you're also interested in the topic and maybe you want to do something together with us.
Super. So yeah, from the audience and also from the panelists who would like to collaborate with Ingrid, that would be really great opportunity regarding the glass quality. So Rojen and Xinrui, so would you like to add anything?
From my side, I would say not specific to N-type cells, but in general, my wish would be to have a glare and glint testing as part of the IEC standard. Right now, it's all based on the ISO 9050. And it is not written in such a way that is specific to PV modules, especially for airports and highways and train lines and things like those. So I think it's high time that there is a proper IEC standard for it, because there's a lot of confusion on what should be fulfilled, because there are IATA standards, there are ISO standards, and each country has their own sort of way of dealing with this. So that would be my wish list.
Nice. Xinrui?
Well, yeah, I think from cell level, I think it's pretty much covered. But I just want to say that we have to make sure that all the current all the current like the types of tests are satisfied. Like, for example, we can't assume that the old degradation we have overcome is no longer there. Maybe it can emerge as we develop the cell structure or module materials. Yeah, we have to make sure all of that.
Perfect. Thanks. So if I summarize, so test cells is all set, and at the module level, it's all about glass. Maybe the reflection or the quality in general. That's a very nice closing remark, and I really thanks all of you a lot for this very nice, insightful presentations and also contribution to this panel. Thanks a lot once again. So yeah, few more closing remarks before I close the conference. Thanks a lot. Yeah, again, we come to our sponsor slide, where we once again would like to thank our sponsor, LONGi, our platinum sponsor, DME GCL, our gold sponsor. Our silver sponsors are Hanzofast and JTPV. And before we close, please also note that we have a few events lined up. So on November 13th, we are going to have a physical event where TaiyangNews is collaborating with ICO and we are doing a workshop on back contact technology. This is happening in Germany. So this event details are already on our website. If you're in Germany or somewhere in this area during this time, please do not miss to attend the conference. And then we also have our flagship event, which we are very proud to announce. So this is usually a 4-day event, and it is also going to be the same. This time we are planning to do it on December 3rd and 4th and December 9th and 10th. So as you all know, back contact technology is really coming more and more into the forefront. So that's why on the day 1, we are covering back BC as a technology. And on day 2, we are covering TopCon. And on day 3, we are covering heterojunction. On the day 4, perovskite and tandem structure. So please mark your calendars and do not forget to join our flagship event. And then coming to our reports, which is another most important part of our product offerings, we have 2 reports. That's the cell and module production equipment, and also the modules and mounting system overview. These 2 reports are essentially the products that were introduced at the leading solar trade shows. And very soon we are going to come up with another version of this report, which summarizes the inverters and the battery energy, battery based storage systems. This will be soon be also online. And with this, I would like to thank everyone. I learned a lot. Hope you have also enjoyed our conference. Thank you very much, and stay tuned with TaiyangNews. Have a great day. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you.